right, that's a little bit of a song that I composed called Wind River Run. Up in Wyoming, there's the Wind River. For some reason, that reminds me of the flow of a river. All right, so last part of this section is just real short, real simple, how we can use trigonometry to find the area of a triangle. So the first kind of key thing I want to look at, I'm going to open up the applet before I go over these formulas and just show you a couple of things on here. There's lots of cool applets that people have put together. So if you're doing an area of a triangle, here's kind of the idea. No matter how you draw this triangle, a triangle can be thought of as half of a parallelogram, no matter how you do that. So if we kind of twist and turn that, it looks like a dancing parallelograms here. So no matter how you do that, you end up really just, it's half of the area of that parallelogram. So that's one way to look at that. The other applet I have is a little bit more specific on that. Shows us like this. So here is a triangle that has a base of 6 and then it has a height of 4. Well, the key thing on finding this area is, again, this is just half of a parallelogram. So if you have a parallelogram is just base times height. So the area of that parallelogram would be 6 times 4, 24. Well, that's half of that. So you would just end up getting the area of the parallelogram divided by 2, so you get 12. So again, no matter how you do this, no matter how you slide and adjust this parallelogram, it's always going to be, or that triangle is always going to be half of that parallelogram. Ain't that cool? Or isn't that cool? All right. Bad grammar sometimes, being from Oklahoma. All right. So let's see. So we'll kind of get on this thing. What we want to look at is developing these formulas then. So there's actually 3 formulas that you can use when you're dealing with a triangle then. So first of all, this works for the side angle side case. This is when you tend to use this. So I'm going to show you the derivation of this formula then. And basically the idea is pretty simple. You know that the area of a triangle is 1/2 the base times the height. Now what I'm going to do is use this diagram. I'm going to write down in words the formula for a triangle is 1/2 the base times the height. However, in this diagram, this base, I'm going to use B for the base and H for the height. So what I end up getting is 1/2 times the base times the height. Okay? But just by using a little bit of trigonometry, you get a right triangle here. So what I'm going to do on this is I'm going to derive, just one formula in here. So basically you can find the height of this right triangle by doing this. So if we do the sine of this angle alpha in here, okay, that would be opposite over hypotenuse. So that would be H, which is the side opposite, over the hypotenuse, which is C. So I'm talking about this right triangle here. Well, I could solve this equation for H by multiplying both sides by C. So I would get the height is C sine alpha. And what I'm going to do is I'm going to replace the height with this expression, and then I'll get a formula which will say the area of the triangle is 1/2 the base times the height, which is C times sine alpha. So if you look at this, that gives this version of the formula right there. Area is 1/2 BC sine alpha. Okay, so that's one way to do that. The other thing you could do is, all right, we could take this same formula. Area is 1/2 base times height. Well, we could look at this triangle then. Okay, we could look at this right triangle, and then we would have the sine of gamma would be equal to the side opposite, which is H, over the hypotenuse, which is A. So you would end up getting H equals A sine gamma. And then this could be plugged in for H. Okay, that plugs in there. So what you would get is A equals 1/2 B A sine gamma. Okay, so that could be written as 1/2 AB sine gamma, which is this version. And to get that other version, it would just be a similar argument, just interchanging these angles like that. So you basically get these three versions like this of the area of an oblique triangle. So if you know an angle in between two sides, known sides, then you can work that out. So the way this kind of works out, I'm going to just draw a little diagram here, a general diagram, and I'm going to label that alpha, beta, gamma. And then this would be side C, side B, and alpha. So what happens on this, it's real easy to remember this formula. So if you're given a side angle side, let's say that you're given the side, then the angle, and the side, then you would just get the area is 1/2 BC sine alpha. Okay, that would be that first version like that. Okay, I'm going to erase these parts. I'm going to go around the triangle and just kind of show you how this goes. Okay, so let's say this is alpha. You know what? This side should be A. I'm going a little fast here. Okay, so we have that. Well, if you were given this, this, and this, then the area formula would go like this then. Okay, so we would have 1/2 AC times the sine of beta. Okay, and that would give this form of that too. So if you were given this, this, and this, again a side angle side case, well then you would have the area is 1/2 AB times the sine of gamma then. All right. So it's just the side angle side case that you're given, and it's 1/2 the product of the two sides and the sine of the angle in between those two sides like that. So that's where the formula comes from. The application of this is actually real simple then. All right. So you don't even really have to look up these formulas to do this. So notice in this example, you're given a side angle and a side. So if you want to do the area, you don't even have to look up the formula. It's just 1/2 times the product of the two sides and the sine of the included angle. Okay, if you have a side angle side case, then you can use this formula to easily crunch out the area of a triangle. So the way I do this is if I can, take half of one of these numbers, I do that. So that's 8. And then 8 times 10 would be 80. Then I'd have 80 sine of 30 degrees. Then I can take my calculator, and then that will give the area of that triangle then. All right, so I just do 80 times the sine of 30. Okay, 80 sine 30 is going to give me what the area of that triangle is. So that's going to give about, in this case, that's going to be 40. And we would say square units. If it's inches or whatever, it's just square units. Okay, so that's the idea. All right. The next problem that I'm going to do is I'm going to draw the triangle just so that you can see what's given here. Again, it doesn't really matter or not whether you draw this to scale or not. So you have your angle gamma is 65 degrees. I'm going to call this alpha and beta. They're both interchangeable. So what you were given in this problem was you were given A, the side opposite alpha, is 11.5 feet. You were given B, or the side opposite beta, is 12.8 feet. So notice in this problem, you're given side angle side. So all you do to find the area is you just do 1/2 the product of the sides, 12.8 feet, times the 11.5 feet. And then you multiply that by the sine of the included angle. And you can do that on your calculator. And I'm just going to do this in one step. The half you can use 0.5, and then times the 12.8, then times the 11.5, and it's the sine of the angle in between, and then this would give you the area. Okay, so that area, we'll just round that off to about 66.7, and again it would be square feet, because you have feet times feet. You're multiplying the two sides, so that's why you get a unit on that in square units. That's all there is to that, okay? So these problems are pretty simple to work out. I'm going to have you try two problems. This first one's is fairly straightforward. You can find the area of that. I've got kind of an extra angle in there. It's unnecessary. And then I want you to work with this number 2. The number 2, you're not given side angle side, but you're given enough information to figure it out. So that's why I say draw a triangle, use law of sines to find a necessary side to use this formula then. So I'm going to go ahead and let you do this. This is going to be a very short video. Just give you the opportunity to work with this formula. Again, you don't even have to know the formulas. You just know that it applies to a side angle side case. It's 1/2 the product of the two sides and the sine of the angle in between. So it's easy to memorize. Okay, so I'm going to pause the video. Let's just spend a little time working on that. When you're ready to check your answer, resume, and like magic, you'll find my answers. Okay? Okay, so here's the answers I got. The second one, you could have went about doing it a little bit different. You may have got a slightly different answer if you went about it a little differently, but you should be close to what I have anyway. The first one is, I rounded it to 42 units. This one's real simple. The 51, you don't even need that angle. Okay, it's just you have side angle side. So the formula is you do 1/2 the product of the two sides times the sine of the angle in between. So all you got to do is 1/2, 9 times 11, sine 58. This is how I put it in the calculator. I just rounded that off to 42 square units. Okay, the second one, you're not immediately given two sides. You always have to have two sides and the angle in between. So you had to use law of sines to work with this then. Now this is the way that I chose to do this. So I was given A and the angle opposite. So I just drew a triangle with alpha 52, side angle A, beta, I don't know B, but I do know beta is 35. And then this would be gamma and C, which I don't know. So what I decided to do ultimately on that problem is ultimately I either got to find B or C. Okay, I found C, but in order to do that, I needed to find that angle. So first of all, angle gamma is 180 minus the two known angles is 93. Then I did law of sines. So I did C over the sine of the side opposite is equal to 12 over the sine of the angle opposite. So by doing that, I found C to be 15.2 inches. So now I've got side angle side. So now it's a simple matter of just doing 1/2 12 times 15.2 times the sine of the angle in between. So I did this on the calculator and got the answer of about 52.3 square inches. Now you could have found B also. So if you would have wanted to find B, then you could have said B over sine 35 equals 12 over sine 52. And if you did it that way, you would end up having on this, you would just have 12 sine 35 over sine 52. I'm going to go ahead and just finish it that way in case anybody did it this way. So what I'd have here is I'd do 12 sine of 35 and then divide by sine of 52. Okay, and that would give about 8.7. Like that. And then if you wanted to do it this way, you could have just done this then. You could have said the area is, and if you used side B in this, there's more than one way you could have done this. You could have done 1/2 B, 8.7, times 12, times the sine of the angle in between. Okay, that would be another way to do that. So if you did 0.5 times 8.7, and then times 12 times the sine of 93, you should get about the same answer. So see, that's 52. That's about 52.1. And you're off a little bit just because of the rounding. But if you did it a different way, you shouldn't be much off from my answer. Okay, you also could have done it this way. You could have done 1/2, and you could have done 8.7 times the 15.2 times the sine of 52. So if you did it that way, that's also okay. I just felt like it was just as easy to try to use as much given information as you can So you were given this side, this angle. So really all I needed to do was find angle C. So that's how I did that. Okay, so hopefully that worked out okay for you. This will be a pretty short video. This gives you the area of a triangle formula when you have a side angle side case. All right, so that's the end of this section, and hope you do fine working with problems on your homework. Let me know if you need help.